In this lesson, we're going to deal with solving quadratic equations by factoring. So this is going to be a pretty labor-intensive video. There's going to be a lot of writing, but this is probably one of the biggest things throughout all of this entire school year. Factoring is huge, and you have to have these steps memorized. The only way that you're going to memorize them is by doing these problems over and over and over. So practice as much as you can. So we're going to factor them and then find the zeros of these quadratic equations. So let's get into it. First of all, things you need to know: greatest common factor. It's the largest term that goes into the given terms evenly. So what are they divisible by? So for something like 2x squared minus 8, they are both divisible by the number 2. For something like 3x squared plus 2x, they don't have any numbers in common, but they are both divisible by x. And then x squared plus 4. They don't have any numbers in common. They don't have a variable in each term. So we actually would say that the number 1 would be the GCF. And that is because they have nothing in common. So they have nothing in common. Okay? So anytime you see something like that, it's very important to know that their greatest common factor is in fact 1. Okay, so to factor, now this is more of like a phrase that you need to know, but when it says to find the factor or to factor something, you find the greatest common factor and you divide each term by it. So looking at this for something like 12x squared minus 36x, these are both divisible by 12 and they're both divisible by x. So what I'm going to do is put that on the outside. So this is the GCF. Put it on the outside. I'm going to take 12x squared and divide it by 12x minus 36x divided by 12x. Okay, so that would leave us then with 12 divided by 12 is a 1, and x squared divided by x makes the square cancel out with the x down here, leaving us with just x, minus x's cancel, and 36 divided by 12 is 3. So we would say 12x times x minus 3. And that would be your factored version of your original answer. Now, a way to check your answer and make sure that you have this right would be to distribute that 12x back through. And do you get 12x squared minus 36x? So if we did that, when we distribute, and I'm just going to write distribute just for your own sake, distribute it through, and we do in fact get 12x squared minus 36x. So now we're going to talk about how to solve them. How do we factor and then solve? So to solve it, you're going to factor the GCF out first, and then every factor that has an x, you're going to set it equal to 0. So let's look at some examples of that. We're going to find the zeros of 14x squared minus 35x. Well, 14 and 35 are both divisible by 7, so they are both divisible by 7, and they're also both divisible by x. So if we take 7x out, and we take these terms and we divide them by 7x, that would leave us with 2x minus 5. And now our second step is to take each factor with an x and set it equal to 0. So we divide by 7 on both sides. We get x is 0, and as a coordinate point, that would be 0, 0. We would add 5 to both sides of our equation to get 2x equals 5. Divide by 2, and we get x is 5 over 2, which would be the coordinate point 5 halves, comma, 0. And your y value, so your y value is 0. So when you write these coordinate points, we're always putting 0 in for the y value. So one more with only 2 terms, looking at what these two have in common. Well, they actually only have an x and nothing else. So I'm going to take an x out, which would leave us with 2x minus 9. So again, setting everything equal to 0, there would be nothing to do here except write our coordinate point. And over here, 2x minus 9 is 0. Add 9 to both sides of your equation to get 2x equals 9, and then divide by 2 to get x equals 9 over 2. So our coordinate point here would be 9 over 2, comma, 0. So this would be 1, 0 of your equation, and this would be the other 0. Okay, so now how do we solve it when a is equal to 1? So you need to write these steps down because you absolutely have to memorize them. I know it's a lot of writing. Trust me, I get it. But you have to know this. This factoring is not going away. You are going to have this all year long. And I'm being so literal when I say all year long. So you need to put it into standard form. Then you need to get your a, b, and c. List the factors of a multiplied by c, add those and see what equals your b term, write your factors, set them equal to 0, and solve it. It sounds like so much more than it really is once you get doing it. And you kind of get in the habit of just kind of going like clockwork. You just kind of go. So with our first example, the very first step was put it in standard form. Well, standard form, remember, is ax squared plus bx plus c equals 0. Well, x squared is first, x is in the middle, last term without a variable. Already there. All right, good. Standard form, done. Now we need to multiply a by c. So a times c. Well, our a term is 1 and our c term is 4. Our b term is also 4. So a times c would be 1 times 4, which is 4. So what are some numbers that are going to multiply to give us 4? Well, 4 could be 2 times 2, or it could be 1 times 4, or any combination. But which one is going to multiply to give us 4 and also add to give us 4? Well, that would be this one right here, 2 times 2. So if we did 1 and 4, the reason that doesn't work is because if we added those together, we would actually get 5. So now what we're going to do is write our factors based on these numbers right here. It's a positive 2, and our second one is also a positive 2. Then we set each one equal to 0 and solve it. Now you'll notice that these are the same, so we don't even need to write that second one really. We don't need to solve it because there's only going to be 1, 0. And because there's only 1, 0, we call this one a double root, which I addressed in the last lesson as well. And then we also say it has a multiplicity of 2 because it's here twice. Okay, so in the next example, so again, still factoring, so we're do a times c to kick off. It's already in standard form. A is 1, c is 8. So 1 times 8, which is just 8. So what are some factors of 8? We could do 1 and 8. We could do 2 and 4. So what we need is to add these together, and it gives us our b term, which is a -6. Well, right now, nothing that we do is going to add to give us a -6. So we need to introduce some negatives. If we did a -1 times a -8, we would still get a positive 8 when we multiplied, but we would not get a -6 when we added. If we do a -2 and a -4, we do in fact get a -6 when we add them. So we're going to write our x minus 2 factor and our x minus 4 factor. And then we set each one equal to 0 and solve from there. So we get x equals a positive 2, x equals a positive 4, which would give us the coordinate points 2, 0, and 4, 0. There we go, and there we go. So those are your zeros for this equation. So now we just have 2 more examples that get a little bit trickier, and that's because our a term is no longer 1. Everything from steps 1 to 4 you're going to follow, but then once you have your factors, you need to divide those factors by your a term and simplify as much as you can. Everything else is the same. There is going to be this little method called slip and slide for fractions so that we get rid of those fractions within the factored form. And that's actually more important later on. So it seems a little redundant to do it now because we'll undo it, but trust me, you need it. Here's the first example. So we take our A, which is 3, and multiply it by our C, which is a negative 10, right? Okay, so A times C would give us a negative 30. We need factors of a negative 30. Well, we know that we could do 30 times a negative 1, right? That would give us a negative 30. But we need it to add to equal our b term, which is a positive 1. So we want numbers that are really close to one another, perhaps negative 6 and 5. But when we add those, we get a negative 1. So if I were to switch the signs and do positive 6 and negative 5, it actually works. So our extra step here that we didn't have in the last one is to take these two numbers and divide them by your a term, which is 3, and then divide the negative 5 by your a term, which is 3. Simplify if you can, which this one we cannot, and then we're going to write our factors. So x plus 2 and x minus 5/3. Now to get these into factors, we need this to be, or to get rid of this fraction here. So I'm going to leave this as x plus 2, but I'm going to do a little slip and slide where you take the 3 and you slide it up in front of the x. So this becomes 3x minus 5 equals 0. And then you set each individual factor equal to 0. So once you solve that, you end up with x equals negative 2, which would be the coordinate point negative 2, 0. So there's one of them. And over here you get 3x equals 5, or x equals 5/3. So your coordinate point 5/3, 0, as your second 0 to this equation. Okay, so just one more example and then we are totally done. So same process as before, a times c. So 8 times a negative 5 gives us a negative 40. Factors of a negative 40. Well, we need them to multiply to give us a negative 6. And this is going to come with time. It's going to take a lot of trial and error to actually come up with these factors quickly. So you'll probably have to sit with your calculator for a while and do some dividing to find what numbers go into 40 to help you out. One thing that comes to mind for me right away is 10 and 4. But we needed to give a negative 40. So what if I did a negative 10 and a positive 4? Well, when we add those together, we actually get our b term of a negative 6. So right off the bat, I've got the two numbers that we need. So take your negative 10 and 4 and divide them, remember, by your a term. So divide each one by 8. Simplify if you can, which in this case, all we can do is divide each of these by 2. And then over here, they both are divisible by 4. Write your new factors. So we're going to write out our factors of x minus 5/4 and x plus 1/2. Do your slip and slide, so bring your 4 up in front and bring your 2 up in front to get 4x minus 5 times 2x plus 1. And then set each one equal to 0 and solve for x. So 4x equals 5, x equals 5/4. And so your 0 would be 5/4, comma 0. So that's your first answer. And then over here we get 2x equals negative 1, which would mean x is a negative 1/2. So negative 1/2, 0 would be your second 0 for this function.